Huh. Because initially they do multicasting. That's what I was saying, router solicitation and neighbor discovery, neighbor solicitation. They will do that in the backend. So let us go ahead and create a loopback over here, right? As of now, I am doing the configuration of these devices. So I gave it an address over here. I gave it an address over here. And I had a ping between them. Let us create one loopback over here and one loopback over here. How will you create a loopback? It is very simple. You should be in the global config mode. Interface loopback 1, IPv6 address A::A/128. Simple as that. So let's copy this and let's paste it over here. Sorry, not this one. Router 1. Configure terminal. Interface loopback 1, IPv6 address. IPv6 address is A::A/128. Simple, just a number. We have to add a number because hexadecimal can have A to F. So you can write anything. Now, about a routing protocol. Here, routing protocols do not have the network command. Earlier, you said router EIGRP1, network and 1111 like that. But here, network command is not there. Here, you have to go under the interface. EIGRP or RIP. Now RIP NG. Here you have to go in the interface and then you have to call the protocol over here. Earlier the network command did two things. It used to send the broadcast out and it used to form neighbors over here. Here it is the same, but the enabling structure is different. One simple command. So let's go on router 1 and let us see. Configure terminal route IPv6. The difference is IPv6 router RIP. How many instances of RIP were you able to run? It was only one previously, because now here you can give it a name. So you can have multiple processes. So the way to start RIP over here is IPv6 router RIP, and you can say Cisco, for example. I am now in the routing protocol configuration mode, but this is IPv6 related. If I did not give the unicast routing command, then it would have given me an error over here. But IPv6 router RIP Cisco, and now you have to simply come out because there is no network command, and you will go inside the gigabit 0/0, and here you will say IP router RIP Cisco enable. Please enable RIP on this route, on this interface. Sorry, this is iOS. So IP RIP Cisco. Just a minute. IP. Just a moment. IP RIP. Oh, maybe it's supported. Just let me check. Oh, sorry. IPv6 RIP Cisco. IPv6 router. Just a moment. IPv6 RIP Cisco enable. The command is correct. This is how you enable RIP on this interface. IPv6 RIP Cisco enable. And again, the same command into the loopback interface. IPv6 RIP Cisco enable. Same command to enable. There we used to give two network commands. Here we give this command under the interface. That is the only difference. And you can see show IPv6 protocols. In here it will tell you that the protocol is RIP and it is Cisco. I am enabling these two, this protocol on these interfaces. Let us say show IPv6 route. All the commands with IP are IPv6 over here. So it says I have connected this network over here and local is this over here. So let's go on the other router and do the same configuration over there. Let's go on router 2 and let's say configure terminal. IPv6 unicast routing is given. IPv6 router RIP Cisco and come outside. Then I will go under interface gigabit 0/0 IPv6 RIP Cisco enable. Simple as that. Now I am not putting the loopback inside here. Let us put the let's not put that loopback in here. We'll put the loopback inside OSPF. Now show IPv6 route. I am router 2. I must be able to see the route received via AA. Let's say show IPv6 route. Do you receive a route via RIP? Yes, it is A colon colon A. I am router 2. I have B colon colon B, but I'm not advertising it inside RIP. So I got the routing protocol properly configured. So I got the route from the neighbor over here, and this is the route he is advertising me. Here it is 2 hop counts away. And here is, you can say RIP-NG supports the latest version 2, no subnetting in all concept. I can also ping A colon colon A because it is a valid number in here. Similarly, you can also run OSPF. So what are we doing here? On this side, we are running RIP, and on this side, we will run OSPF, right? So let us go ahead and do that. So let's go on router 2. Router 2 has which interface? It has gigabit 0/1, isn't it? So let's go on configure terminal. Interface gigabit 0/1 IPv6 address is 23:1/64. Between 2 and 3, it is the 23rd network, and I will say no shut. This is IPv6 address assignment and turning on the interface. Okay. Similarly, I will create a loopback. I think I created a loopback. Show IPv6 interface brief. Yeah, I have a loopback. I'll create a loopback also. Interface loopback 1 IPv6 address B colon colon B/128 exit. Now, if I say I want to run OSPF over here, same configuration but a little difference. Here you will say IPv6 router OSPF 1. Simple as that. But here this router is purely an IPv6 router, because on any of the interfaces you don't have an IPv4 address, right? So your OSPF says something to you. He says no router ID. He says OSPF version 3 process 1 could not pick up a router ID. Please configure manually. Here he says, please give me an IPv4 address over here. IPv, the name it will always take as IPv4. Router ID is just a router, the name of routers in OSPF. So here it says, I will use my original names. I will use my native name. So it is very important to understand that if you are running OSPF in version 3 in IPv6, you must assign a manual router ID to this guy. If there was an interface loopback that had IPv4 address, then no problem, but you should manually assign OSPF router IDs. I have an option to shut down this protocol also. EIGRP is shut down. You can also shut down these protocols. In EIGRP, it's there. OSPF will also support this. Let's say now, so I said IPv6 OSPF 1 and the router ID, and I came outside. Now, this interface is in area 0. Let's put it in area 0. Let's go under the gigabit 0/1. It is gigabit 0/1. Yes. So I will say IPv6 OSPF 1 area 0. This is how you put an interface into OSPF. IPv6 OSPF 1 area 0. And I will also advertise my loopback into it. Interface loopback 1 IPv6 OSPF 1 area 0. So I'm running RIP on the other side and OSPF on the other side. If you see here, I am running RIP on this network and OSPF on this network. But still the last configuration is remaining. So what we can do is, now here I will do a mistake. I will not give IPv6 unicast routing. Then let's see what the error comes up. So let's go on the third router. Let's click in here and let's say Control C, enable configure terminal, hostname router 3, interface gigabit 0/0. It has an IP address, IPv6 address 23:2/64. No, shut it down. I am turning it on and exit interface loopback 1 IPv6 address is C:/128. And now I want to run OSPF over here. I will simply say IPv6 router OSPF 1. What does it say? It says IPv6 routing is not enabled. So that means the previous command you did not fire. So it's IPv6 unicast routing. After giving this command, it simply starts OSPF. And then it is asking for a router ID. Okay, take the router ID as 3333. Simple as that. And then you will go on interface gigabit 0/0 IPv6 OSPF 1 area 0. All the concepts, LSA types and all are same. Just the creation is different. Interface loopback 1 IPv6 OSPF 1 area 0. This is how we add an interface into OSPF. Now I can say show IPv6 route. I will be able to see the route. As of now, OSPF is a little slow over here. It takes time to get the adjacency. Down, attempt, init, two-way, extract, exchange, loading, and done. It will go through all these stages. Show IPv6 OSPF neighbor. If it is the DR other, and let us say show IPv6 route. See, it became full. Now I will be able to see the route here. It is connected. It should see B::B. Yeah. See, I am receiving a route from OSPF, and that is B::B. AD is same 110, and you can say metric is 1 because it's using a gigabit link or something. So I can also ping B::B, but I am not seeing the routes of A::A. Why? Because see, here we are running RIP and here we are running OSPF. These two protocols will not merge, right? So here on this router, you have to do redistribution. It is not important for us to learn redistribution with IPv6 and CCNA, but it's just 2-3 commands and we'll do that. As of now, see on the third router, we are not able to see A::A. A::A. And that's what we will do now. Here, A::A must be seen. This is the task that I give you, for example. So you are supposed to redistribute on this router because it has one interface in RIP, one interface in OSPF. After doing redistribution, this guy will become the autonomous system boundary router, ASBR. Let's do that. Let's go on router 2. See, it is very simple, pretty straightforward commands. See, I'll show you what will be the command for doing that. Just increase the font for a little bit. 22. Yeah. So I will say configure terminal IPv6 router OSPF 1. I will say redistribute RIP, and that's it. Subnets is not required, but you can also use this keyword subnets. Let's do that. And here you will say IPv6 RIP, IPv6 router RIP, Cisco, and here you will say redistribute RIP. Let's do on this device itself, router, this one. Maybe I do some mistake. Yeah. So let's do that. Let's say IPv6 router OSPF 1, router OSPF 1, redistribute RIP, and it a question mark, Cisco. That's it. Redistribute RIP. We used to say redistribute RIP subnets, but here we will say redistribute RIP Cisco. And if you hit question, you can choose the metric type. Only one command in here, redistribute RIP Cisco. Here we will say Cisco, the name of the process. And now we will go inside RIP and we will say redistribute OSPF 1, and metric will be 1. This is the seed metric, right? So we will go in OSPF, exit IPv6 RIP, IPv6 router RIP, Cisco. Please redistribute OSPF 1, and you can say metric is 1. This is a seed metric. We are adding 1 hop count for RIP. Simple commands, 2-3 commands over here. Inside OSPF, you will call in RIP. Inside RIP, you will call in OSPF. Just the same thing. Let's go on router 3 and let us examine that. Earlier we were seeing only B::B, but now If the redistribution has been done perfectly, you will see OSPF external type 2 route over here and A::A. So our task was that this router must have the route of A::A, and that is what we accomplished over here. So by doing redistribution on the ASBR, the router that connects both, we achieved this task.